We're going to talk about tricked out my traces. And you will see if anyone is working with OpenTelemetry or with observability solution. There's a topic which is complicated. It's called sampling. So here's going to focus our effort of this session about sampling. All right, so let me introduce myself. My name is Henrik. Said. I'm a cloud native advocate working at Dynatrace, a bit more than 4 years now. Focus on open source stuff, Kubernetes stuff, and otherwise it's been since a year and a half, less than a year and a half, I don't know. I'm a CNCF ambassador, and yeah, I like the observability community. I like the cloud native community. It's a very warm, welcome community. I love it. But before that, I used to work as a performance engineer, so more focus on testing, breaking, tuning, optimizing, making sure that it works. And I think it's an amazing practice because you're touching so many architectures, so many different patterns. So if someone wants to learn how different architecture pattern, I think it's an amazing practice. So that's why I still try to produce some content on a YouTube channel called, it used to be a podcast, which we are transitioning to YouTube, called Perf Bytes. So very focused to performance engineering. And since for less than 4 years now, I am hosting this YouTube channel called Is It Observable? Yeah, you have it in the name. It's about observability. All right. So, what if you pimp with me? Sorry, I shouldn't have done. If you pimp with me the next 20 minutes, what are we going to touch base? Well, we're going to cover about the importance of sampling and why we need to sample. And then also we're going to talk about the reality of distributed tracing applications. And that will be a good excuse to remind what we have as of now in OpenTelemetry, which is head sampling. So we'll cover those head sampling decisions. And we'll jump into the collector sampling. And then there's a proposal that is on the way and available in a few languages called consistent probabilistic sampling. So we'll explain for those who never heard about that, what it is and what's the value of this at the end. I think it's a great future for OpenTelemetry. And then I will share some best practices about the collector, specifically if you use tail sampling in the collector. All right, so let's start. So since OpenTelemetry arrives and open standards, we are pretty proud of ourselves. We're producing tons of traces, tons of metrics, tons of logs. We go to dashboard, we generate those dashboards, we generate SLAs, we create alerting, and Dan, we are very cool kids. We're pretty proud of ourselves. I love it. But wait a minute. Let's remind the engine. We use an engine. Maybe we have to check about the engine itself. So what is the engine? I mean, I'm not going to teach about anything about, but this is distributed traces. And distributed trace, it is made of spans. So you have a root span that will hold the actual duration of your trace. And then inside of that distributed trace, you will have some spans. Spans could be an error, will hold different details. So if one span is an error, technically, our trace should be an error as well. And then you have the complexity of a transaction, which is the depth of the number of calls that we have in our trace. So that's very simple. And then when we are producing those traces, we are sending it to an observability backend. And that observability backend, any observability backend in the world, is going to extract data from the trace, and is going to calculate failure rate, response times, throughput, get some endpoints, get some statistics about it. And this is where we are very happy about this, because then we can do some graphs, we can do some SLO, some SLI, or alerting. So that's amazing. So question is, why should we sample? Well, let's remind the importance of sample. I don't know how many of you are running. So let's take the example of a running race. So Kate and Mike organize a small running race in town, and we have 20 people running that race. And then Kate and Mike says, oh, we all want to get some statistics about the runners. So Kate sits on one stage of the race, Mike on the other, and then they check they measure the timestamps on each stage, and then from there they get some statistics. So here, with 20 runners, no big deal. We're not sampling. We're taking everything. Now let's take the average marathon. We have about 35,000 plus runners running that race. And here, Kate and Mike, obviously you cannot keep it track on each timestamps of each runners. So Kate and Mike naturally will say, oh, we're going to sample. And I'm going to keep track. So Kate says, oh, I'm going to take 30% of the runners going through my stage. And then Mike says, oh, I'm going to take 20% of it. So then Kate and Mike says, oh, technically we should have the minimum of both, which is 20%. It's basic statistics. It's going to be 30% multiplied by 20, and at the end, they're getting 6% of the actual runners. So they are making beautiful stats about the pace of whatever happens, but at the end, it's only 6%. Does it really reflect all the runners, how they are actually behaving during the race? Not really. So this is actually what happens when we're sampling. So we have a distributed system, and we have different stage, different microservices. And then at the end, we have one services that says, oh, I'm going to sample at 30%. And the other one says, I'm going to sample at 20%. And then we ending up sending it to a backend only 6% of the data, which is quite a low. And remember, with this 6% of the data, we are getting error rates, response times, SLO, dashboard. That sounds super, I mean, I'm a bit afraid of that, you know. Can we really rely production stuff with something that doesn't reflect real life production? I don't think so. So the other reality that is happening is that we have a distributed system, and then one of the services, like the service A, has different endpoints, /order, place order, /health, /customers, or /products. And obviously the number of times those endpoints are being used is completely different. It makes sense. So you probably have a lot of good health. You're probably going to have a lot of get products. But my company is really focused on place order. See? So if I apply a fixed ratio of 20%, then yes, I will put 20% on everything. So I will have less spans on place order. So not considering the actual usage of critical functions could be also harming our statistics. So what is the solution for this particular problem? Well, if you're not aware, the OpenTelemetry Collector has a Spanmetrics Connector. So the purpose of this, a connector is basically you take your traces, you're sending to the connector gets from the traces, will produce OpenTelemetry metrics from the traces. So you will have response times, the number of requests done by any endpoints, and then you will export it as a metric, so then you will go through your metric pipeline. So at the end, if you apply the Spanmetrics Connector before you do any sampling, then you're sure that you get metrics which is reflecting production. You get everything. All the requests, all the response times, and then you can build graphs like, say, I want to have the requests per second split it by services. I can look at the response times. I can look at what are the status, the errors. So at the end, everything that we were looking at initially, if we rely on Spanmetrics, we are quite precise because we are taking 100% of everything to get these details. Now, let's cover the actual, so that's for the distribution. But now let's remind what we have actually in our project in terms of head sampling, and then we'll cover collector. So head sampling, I think it's great, but you see that there's a balance on bad, and I will explain why. So the first thing is you have there's a combination of different ones, but you have 4 current head sampling decisions available. You have always on, so you take 100%. You have always off, the opposite, a switch off, so I have 0%. You have parent-based, and then you have trace ID ratio. Parent-based is basically used for dependency. So I'm a service depending on the front end. I will only produce spans where there is a trace parent, meaning that it's perfect for backend services, makes sense. But the other downside of it is if I have a get health running on the background, or you have any asynchronous call running on the background, this will be sampled, or I will never receive those. So if I have something is unhealthy by Kubernetes, sometimes it makes sense to get the spans to understand why it's unhealthy. Then you have the other one, which is trace ID ratio. Remember Kate and Mike taking the 30 and 20% example that we did initially? This is exactly the thing. I do okay, I'm going to apply on the front end 25%, on the checkout 10%. I will apply 10% on the payment. So at the end, what it does is that locally at the component, it says, oh, I'm going to only take 10% of it, and I'm going to throw it to the collector. And then he will mark in a trace context a flag to say, hey, I have been sampled. So then the other can take advantage of that. So if I do bad configuration, so here it's an example of a bad configuration. Let's say I'm really focused on getting spans about the payment transaction. So we do the math. 25% multiplied by 10%, multiplied by 10%, then it means that I will have only 0.25% of spans with the payment span. So very, very limited number of assets to take decisions. So here is a very bad configuration. So that's why there's a current working on group, this consistent probabilistic sampling that resolve that. And it's only available in 2 languages as of now, so Java and Go. And how it works is very simple. The first thing, we go back to the example of Kate and Mike. We have Kate and Mike. And here Kate and Mike says, oh, instead of taking random 20% or random 30%, I'm going to rely on the bid number of the runner. And here Kate says, okay, I'm going to take all 20% of all the runners having a bid number which is under 200. And then Mike will do the same thing with 30%. So at the end here, we are actually having a min of both, which is 20%. So more accurate. Instead of having 6% of the initial example, I'm getting actually 20%. So much more precise. So that is wonderful. And if you could take back to the example of distributed tracings, remember, our distributed traces also have the bid number. It's a trace ID. The trace ID is the bid number. So how it goes, very simple, is basically it needs a hash, which is a trace ID, and it's going to rely on that hash to say whatever is value, I'm taking it's going to be higher to the hash, and it's going to be sampling. And the other great thing about consistent probabilistic sampling is adding a new field in the trace context called trace state. And you see, there's OT for OpenTelemetry, and there's 2 fields. One is holding the hash, called RV, and the other field is called rejection thresholds. That holds the actual decision made by the component. Meaning, if I'm sending something back to the observability backend, the observability backend knows exactly, oh, this has been sampled at 10%, so I can extrapolate more precise statistics out of this experience. You see the formula for to get this array. What's the field name? TH is 1 minus sampling ratio multiplied by 2 exponential to 56. So you can calculate back the sampling rate decisions. So this is amazing because at the end you will resolve, first, make sure that the stats are accurate, and the other thing is more realistic sampling decisions from the head's perspective. So this needs to be available everywhere. Cross the fingers that it happens. Now we have the collector sampling. So collector sampling has 2. One, there is the probabilistic sampling, and then the other one is tail sampling, where you're going to basically take entire traces, store it, and make a decision out of that. So let's look at it. So probabilistic sampling is basically you can sample traces and logs, and the decision on the algorithm applied on it will be based on the mode. So you have hash seed that is really designed for logs. You have proportional and equalizations. And equalization is basically both of them depends on make sense if you have pre-sampled your spans and if you have consistent probabilistic sampling your spans. Because here it's proportional, it will take what you have applied. Let's say I've already applied 20%, and we say we want to sample at 10%. He will say 10% multiplied by 20%. Equalization is different. Here we want to have I'm targeting to get 40%. So he will, based on what you pre-sampled, he will recalculate the right sampling decision to get the actual 10% or 20% that you defined. So which is great. And the other advantage of this, it's basically storing in a trace context the actual sampling decision. So back to what we've seen before. Then the other one is tail sampling. I call it sampling like a pro, because at the end, the idea is that you have your pods, they're sending their traces to the collector, and then the collector, at the end, what we want is to apply some rules to get some different status of rules, I will explain the rules in details, but with those rules, we will make a decision on the actual trace. So to make the actual decision on the actual trace, I need to store all the spans. So meaning that the collector will store in memory all the spans, so the memory will grow, and then apply these sampling decisions. So great, but you know that you will have some memory consumptions. What are the rules that we can apply? Well, you can do rules based on error, so the status code of the trace, the latency, the size. Let's say I'm only interested in sample the traces that has at least 8 spans. I want to have a sampling decision based on labels, attributes. I can do that. I can also rate limit. If I see that there's an endpoint that is very producing a lot of spans, I can rate limit it through the sampling decisions, and then I can also apply a probabilistic sampling. So you have all the toolings to do very, very, very complex rules. It's an amazing processor. I really recommend to use it. Then to be able, when you apply this, like I said, you're going to consume more memory. So this is where you have to define the timeout, how long the collector needs to wait until get the actual trace. And then the number of traces that we're going to keep in memory. And the last is the cache size. How many, what will be the size for the sample traces, and on the other hand, what will be the size for the non-sample traces? So this is very important, because at the end, we will control a bit more the memory. So when you do this, you need a proper architecture. So first, I will use one collector that will do the enrichment. And then it will basically generate the span metrics. So then I know 100% of the spans arrived on the collector. I produce the metrics. And then I load balance my traces to different instances of the replica of collectors. And those will be load balanced based on the trace ID. So I know that it will be always send it to the right replica. And then at the end, I'm sampling it. And of course, one thing which is important when you start doing those tail sampling, you have a metrics to be enabled, which is not enabled by default on the collector. This is a feature flag that you need to enable on the collector, and this will give you some stats about how many traces has been sampled. So then you can recalculate the trace the ratio, the sampling ratio that you've applied on the traces. So to be able to understand what would be the right settings for tail sampling, I did a small benchmark. So let's go for the benchmark. So the first question that I had when I did that benchmark, I say, does the number of rules in tail sampling impact the resource consumptions of my collector? So I did one test with 2 rules, so one with the status and latency, then 3 with adding some conditions on the attributes of the spans. Then the 4th one, I added some probabilistic sampling on the top. And then last, I did some condition on the HTTP status code and the condition of the gRPC status code. And last test that I did, so 6 policies, plus I started to say what would be the consequences if I don't have caching enabled and if I have caching enabled. So to see if there's any improvement on the resource usage. So I have a repo here where you have all the examples. You can check the QR code. So like I said, I will have 1 daemon set of collector for the logs, 1 stateful set for traces and metrics, and then 2 replica of collectors to do the tail sampling. I have 2 demo apps where I'm doing load tests to generate more traces coming in the systems, and I also added intentionally Istio to add more spans. Istio will add 1 spans incoming traffic and outgoing traffic on each individual sidecar proxy. So let's look at the results. First question, does the rules impact the consumptions of our collector? Well, so here you have the load. So here you have the number of incoming spans. So I have a flat, a constant load, and then every 2 hours, I generate some spikes. So you can reflect that on the incoming spans. And then this is the various collectors that I have here on CPU usage, and this is the memory. At the end, as a consequence, there is a slight difference in memory. I would say rules will consume a bit more memory, but it's insignificant. It doesn't change the actual memory usage of your collectors. And then I said, okay, what is the value of caching? So then I applied the caching, and you can see here the blue line. The blue line, which is, the blue line here is the sampled collector, and same thing on the bottom. You can see that here by applying the caching, I'm saving some millicores, and I'm saving some memory. And one last thing, you can see that the memory of the collector is increasing. Then this morning I did a test, so I didn't update the slides. I thought, let's do the metric conversion, because here you can load balance your metrics to do the metric conversion. I have now I removed it. So in the new test I have here on my laptop, obviously you cannot see it. Yeah, I was basically worried because the memory of the collector was increasing forever. And I say, shit, there's a memory leak here. And in fact, no. If you remove the cumulative delta metric conversion, then the collector sampling is flat, very flat. So no impact, no memory leak. I'm revealed, to be honest. So you can use the collector to tail sample and without having this extra memory. Okay, so let's take away. What we touch base here today? A couple of things. So first, if you use head sampling, if you use head sampling, I would say use parent-based, but you will just remember the health check and every asynchronous call will be sampled. You won't have them back in your backend. Use trace ID ratio with cautious. I would say don't use it. And then do tail sampling. I'm more in favor of use tail sampling. So use a collector to use tail sampling and then build the right rules. I want to have errors. So you want to have a distribution of things that reflect your real life production. I want to have errors, slow production, so slow response times. I want to have spans that are really big because it's very complicated. I want to rate limit the endpoints that are very chattiness. So create the right rule for your need, and then you will have the right data back in your backend that you can trust. That is the most important things. And if you use tail sampling, remember, enable the collector metrics, because at the end you want to basically extract what is the ratio that you have applied in your system. Otherwise, you're a bit blind. And if you use tail sampling, use several instances of the collector. That is a big requirement. Take advantage of the load balancer exporters, because at the end it will be a smart way of making sure that each spans of a given trace are sent to the right replica. And I think that's covered most of that. What I needed to cover. A small teaser on the Is It Observable channel. I have a dedicated episode on sampling, covering in details all the algorithm. Check it out, it's out there. Love if you love and hate if you hate, but just give me a feedback. That's the best way of improving content. All right, do you have any questions? Oh gosh, did I kill you? I mean, I think I was. Don't be shy. Did you learn something? Yeah? Okay. No? Yeah? Okay.
So thank you, Henrik. I think it's a very great insight. So as this is one of the very interesting topic on the sampling. So one question I had is like, with all the tail sampling logic, right, you have, what's the probability on your results, right, that the whole transaction trace, which is obviously involved in multiple different services, spans coming from multiple different services, the chances of that the complete one transaction is coming up with the sampling strategy?
Yeah, if you do the simple trace ID ratio, you are putting more chance to limit the number of potential end-to-end traces of your back-end services, especially if you're looking for a service that is very at the end of your microservices. It's going to be narrowed down on the number of data that you will have. So that's why I think consistent sampling make at least more chance for that, right? To get more ideas. And I think that's why tail sampling makes so much more sense. And I think people people usually don't take the sampling exercise as a serious question, and it's super important because at the end you're producing very valuable assets. And then you're just throwing out half of it, and then you're looking at things you're very proud because you look at the distributed traces produced, but you don't know what that trace come from.
Yeah.
So I think, I mean, in the best world, I would say, if OPAMP was ready for all the cloud instrumentation, I think that it's a vendor decision because it used to be a vendor problem, and now we're giving it back to users. And I think if OPAMP had the options to let the observability vendors reach out, because this is what, for example, my company is doing. Our servers are reaching out to our local agents and says, now give me more data, or we are controlling dynamically the sampling on the fly. And if OPAMP was there, then we could do that. And I think that will resolve so much the challenge and avoid having people, oh, I'm overspending spans because I'm sending 100%. But yeah, 100% doesn't make sense.
I think you mentioned that you had I think you did the Spanmetrics, then the load balancer.
Yeah.
What are your thoughts? I think we found in ours when you scale large, we also had to use load balancer for the red metrics to get proper aggregations, and like once it gets written to the backend TSDB, like totals and things. If they went to different collectors, it doesn't, it doesn't know.
Yeah, that's why I think that's why I usually use one instance that gets everything, and from that was in charge of doing basic transformation like the enrichment. And this is where I'm going to produce, because I know that 100% of the traffic will go through that.
Yeah.
At least from a given application, because if you have a lot of application, you can have different collectors that do the same thing. But at the end, you're producing the actual numbers, precise numbers, and you know that it's going to be one instance will have all the data flowing in, and you will get the right stats.
But if you were to scale, I guess when you start to need multiple instances due to scale, then you kind of may need to use load balancer for this.
No, so I use one just for that, and then I use the load balancer exporters, and then I use a stateful set. And then you can use HPA if you want, because then in the Kubernetes world, the load balancer can basically resolve the number of replica based on the number of instances. But again, it's a bit untrue, because you start doing. If you start sending your traces and then you start adding a new one, then you could basically drop. I never tried that exercise to dynamically use the replica if I get screwed in my tail sampling decisions. But yeah, I will spread out, use the load balancer. You can use the load balancer for metrics, where each metrics will be sent to the right replica, and same thing for the traces. Oh, if you have any questions, I will be in the corridor to answer them. Thank you.